Hello and welcome back to CERN. You know, the ATLAS experiment over the next couple decades is going to be producing tremendous amounts of data. So us physicists here at CERN are very much interested in looking at all of this data to try to find new and exciting physics. But sometimes strange things in the data can also indicate that there's a problem with our detector. So how do we go about monitoring the data to check the health of our detector? Let's go talk to my colleague Andreas and find out. So Andreas, we're here in the data quality control room, and you are the data preparation coordinator. What does that entail? What does it mean to prepare data from ATLAS?
The data taken by the detector in the cavern is sent out, and then when the trigger has said this data is good, it's accepted, it is sent to the computer center at CERN. There's a very fast connection between here and the computer center, and then all the reconstruction machines are sitting in the computer center and making prompt reconstruction, which we call. So once the data arrives there, it's right away reconstructed. It is also analyzed here online. This is in parallel to the data arriving over there, and so people look at these events and at distributions to understand the quality of these events and to give fast feedback if they see a problem directly to the control room people working downstairs. And we fill lots of histograms and monitoring plots to again look at the data. So then there is also the people sitting in this room who are looking at the what we call offline data quality, which is far more advanced and more precise information than online.
Do you actually look at every single picture like this to see if something's off?
We did this at the very beginning, so we were really seeing here at every picture, every of these events we were looking through. Because in the very first round we had only 200 or so events in total, but now we have, of course, 200 events per second, so we cannot do this anymore. So we analyze about every 2 minutes, and so if there is a problem in these 2 minutes, in these distributions, we will mark them as bad and try to understand why, of course.
So Andreas and his team will be receiving data at a rate of 200 events per second. They're going to quickly analyze all of that data and get feedback to the physicists within 2 minutes after there has been the collision of the protons.
See, the real ATLAS performance will only show up really with very high energy collisions. So we will be able to use the full detector as it was designed. And we will be able to have far more information on understanding the detector's response, to do calibration, to do alignment, and to search for, of course, new physics.
How high of energy is that compared to, I don't know, my car driving down the road? Is it a really high energy?
It's about the energy of a flying mosquito. The main point is that the energy has to be concentrated on a very, very small spots. The energy of your car altogether is a huge amount more than the 70 EV energy.
But my car's not going to create new particles.
Your car, because it's too big.
So while the energy of the collisions in the LHC are actually pretty small, they're similar to a mosquito in flight, and that's much smaller than the energy of, say, my car when it's running. Still, that's 7 times any energy we've ever had before in a collider like this. It's going to allow us physicists to find new and exciting things.